Hello, I'm Dr. Judy Murphy from San Joaquin Delta College's Microscopy Technology Center. We have a unique 2-year program for training microscope technologists. During that training, they have to learn various types of specimen preparations for the various types of microscopes that we use. One of the types of microscopes, in other words electron microscopes, require that the specimens be very thin. To do that, then, we have to have instruments to cut them very thin. In today's video, we would like to show you how to use an ultramicrotome. The ultramicrotome then allows us to get thin sections that can be viewed on the electron microscopes. Before we do ultramicrotomy, however, we must have all our materials together. So as you can see on this list, the first thing that we would get would be to have our specimen chuck for the particular microtome, a well-trimmed specimen block, good quality knives, clean grids, good quality grid handling tweezers, trough liquid such as filtered water, an eyelash manipulator, chloroform for flattening specimens, filter paper, a petri dish, a loop or tweezers for collecting thick sections, a grid box, grid glue, and a knife cleaning stick. Once we have those materials, then we're ready to learn how to do the process of ultramicrotomy. The process of microtomy includes, of course, checking the logbook, doing the basic checks for the instrument, mounting the block, setting up the knife, adjusting the stereo microscope, adjusting the specimen and the knife, and these have to be critical parallel adjustments for both the knife and the block, approaching the block to the knife, setting a cutting zone, selecting the cutting speed, filling the trough, facing the trimmed block, and then collecting sections. Today we are very pleased to have with us from Ventana RMC Incorporated, Mr. Gregg Carter. And Mr. Gregg Carter is going to go through the demonstration of exactly how to use this marvelous microtome, the MT XL. Gregg?
Thank you. The MT XL Ultramicrotome is part of a long line of ultramicrotomes that began in 1953 by the Ivan Sorval Company. The MT1 Ultramicrotome was a hand-cranked microtome that was non-motorized. In the 60s, that was the MT2 and 2Bs. In the 70s, it was getting into the more electronic ultramicrotome. Then we had the MT 6000 XL, that's all microprocessor controlled. MT 7000, that was in, I believe, 1990. And now we have the version called the MT XL. And this ultramicrotome is the latest improvement in electronics and mechanics available. You have a controller that controls all the electronic functions. This is what you set all your parameters with. And then you have the workhorse, which is the ultramicrotome that is primarily the cutting arm and the stage assembly in its own frame and casting. First thing we need to do is power the system up. In order to do that, over on the back left side of the controller, there is a power switch. When that is pressed, the unit activates, turns on, and you see a reset red light comes on. The unit will automatically fill up the gas tank, basically reset the advance mechanism. You now have 200 microns of advance available to you. The next thing we notice is we have a double beep every few seconds. What this is the ultramicrotome is asking us to rotate its hand wheel, maybe a half a rotation to a rotation. It's just enough for the ultramicrotome's electronics to go through a built-in self-diagnostics test. Once that's completed, and we've stopped in the downward cutting stroke, the unit is then ready to start setting parameters. First thing that we want to do is over on the controller, we have what's called the lighting system. Throughout the controller, you notice a symbol of what is called a specimen holder. So we want to use that symbol as a reference to what we're doing here. So if you look at the lighting system, you have the specimen holder with a yellow light shining down on it and one coming up from the bottom. So if we depress this button, which is the top light, you'll see that the fluorescent light just under the stereo microscope is now illuminated, lighting up the cutting area of the ultramicrotome. So we'll start with that. Once we have that illuminated, the next thing we want to show you is how our scope and everything works on the microtome. To begin with, the lighting source being this is the fluorescent, what we call top light. By loosening this knob right here, you're able to raise and lower the light. The ability to raise and lower the light and the ability, if we lock it down, to adjust the reflection direction of the light, you can then get an excellent silver reflection off of your boat water, which we'll be doing later when it gets down to the final sectioning process. The scope itself, what we call boom, moves to the front and rear of the microtome, and this is for when, for example, you're getting ready to approach or take sections. You want to look right at your knife edge. But once you've accomplished sectioning and you have a number of sections in your boat water and you want to, for example, collect them, you would want to move the scope towards you a little more so you can see the back of your boat and see where you're collecting your sections. The next knobs that we have here, and all of these are right and left-handed. The next set is for your focus. This raises and lowers your scope. This knob here, this is for your focus, which is, or I'm sorry, your zoom, either wide field or high magnification zoom. This little knob right here gives you a tilt of your scope. This is for when you're especially on high magnification and you find yourself kind of looking sideways through the scope. What happens is, if that's the case, you're going to want to push the scope a little to one side, a little to the other. But what you'll find with this microtome is using this knob, you're then able to do a very fine tuning of the scope back and forth to get yourself centered. Another thing with this arrangement is the ability to raise and lower the scope. Not only does it make the ultramicrotome very comfortable to use, so you can adjust it to your height and so that you're comfortable when you're sectioning, but it also becomes important being able to move this scope during alignment, which you'll see later is important. You'll want the scope up a little bit higher than normal, and then when you're actually taking sections, you're going to want it down where you're very comfortable. So this scope does have the ability to raise and lower. Now we start out with, on the ultramicrotome, we're going to need to begin trimming your block. And how we do that is what we call our trimming block, our trimming post, and our specimen holder. Now with the specimen holder, the jaws internal can be utilized for either using a round beam capsule, or you can insert a flat mold. You then use the red wrench, comes with the system, and this is used to tighten down your specimen block into the specimen holder. Then insert your specimen holder into your trimming post and secure. Secure your trimming post to your lower stage, and then this knob on the right, part of the lower stage, when you tighten that down, it makes the entire assembly secure in order for you to then utilize using a razor blade, etc., to trim your block face. Now, once you've trimmed one side of your block face, you can then loosen this front knob here, rotate 180 your trimming post, secure your trimming post again, trim the other side, and then you now have two parallel edges, and then as directed you can either trim it as a trapezoid or a rectangle, but it gives you a very secure mounting for trimming. Once you've trimmed your block, you can then remove it with your red-handled specimen tool. Take the entire trimming station off, and then you have your geared arc segment holder, which is what you are going to then mount your specimen holder and your block into. Now your arc segment holder has lines on the side that tell you what the angle of the arc is. When you start out with trim or sectioning, it's always easiest to start at 0 degrees, because at 0 degrees, if you ever need to recut your block, you can always just start at 0. But it is graduated to plus or 0 to 20 plus or minus. The next knob is the one that gives you your 360-degree rotation of your specimen holder. In order to see that, we're going to have to insert a specimen holder. Now, to secure a specimen holder, we have holes in the side of the arc holder in which, when you insert your specimen holder, you then take the wrench, insert it into the hole, and you will see with the set screw, when it's in the hole, you can tighten it and then tighten down. That secures your specimen holder. Once you start rotating your specimen, the hole is then not able to show the set screw. So you may need to rotate until you see the set screw show up, and then you can remove your specimen holder. A simple rule of thumb that has worked very well is when you insert the arc segment holder into the cutting arm, if the set screw that you use to lock your block or your specimen holder into your arc, that you use to secure your block into your specimen holder, if that's at 3 o'clock and you tighten your arc segment holder in at 9 o'clock, you then know that whatever rotation you've got, if you want to remove this, just get this over to the right, and your set screw is always going to be there over to the left. You don't have to search. Okay, we'll lock that back down. And we'll put our beam capsule back and secure. Now we need to look at the stage arrangement on this ultramicrotome. What we have here is what's called an upper stage and a lower stage. With the upper stage, its primary use is obviously to hold a knife and to be able to adjust the knife so that it will be parallel with the black face. We can do so by adjusting by degrees with the right and left knobs here, or as some people like to do, they like to be able to rotate the entire top of the stage to view the back of the knife, as can happen with diamonds that are used on a regular basis. You're then able to look at the back of the knife without having to crank and turn and turn and turn. It is a slip clutch arrangement. Now, if we're going to use glass, the procedure of making glass knives will make them just a little short of 1 inch height. So that's why you may want to utilize what is called a glass knife spacer. Glass knife spacer is inserted into the knife holder that's in the very top of the stage. The knife holder is secured to the upper stage by this knob on the right, and you see we can then remove the entire knife holder. Put your knife holder back in, but before you tighten it down, you have to set your knife angle. Generally with glass you're around 5 or 6 degrees. This is the setting right here. With diamond, go by what the manufacturer recommends. Some diamond knife manufacturers recommend an included angle of 4 degrees. Others recommend an angle of 6. So we're going to set this using the glass, let's say at 6 degrees. You can just push your knife holder down, bring it up to your 6 degrees, and then with the knob on the right, secure it. You can then put your glass knife in your knife holder. The knob on the right, this is with the knife holder. You can then tighten your glass knife down. And then what we have in our design is what's called dovetail. What we mean by dovetail is if you look at the upper stage and you look at the lower stage, they're mating in a dovetail pattern. This is a very secure mounting. In placing the upper stage into the lower, it's easy just to get it started on one side and then rotate, and normally she'll just slide right in nice and easy. If it doesn't, it's usually because you have to loosen your knob a little bit from your trimming station. Moving it up into position so that your knife is relatively close to your block. Secure your upper stage to your lower with this knob here. We have now done our gross advance to the block face. Pen. We have now done our gross approach to our block face. The next thing we need to do is align our knife to our block face as best as possible. One thing is centering the knife to the block face, and that is done by the lower stage. The knob on the right-hand side gives your lateral right to left movement of the stage. Rotating in one direction will take it to the left. Rotating in the other direction will take it to the right. Now once we've accomplished centering the knife to where we want the block face to be sectioning or trimming onto the knife edge, now we need to move the knife closer to the block face. And how we're going to do that is first by moving your scope over into position so that you can see through the scope how close you are to your block face. I can see I need to come towards the operator a little bit, looking straight down. Go to a little higher mag, and then give a focus. A little more centering. And now I see that I need to rotate the block so that I'm a good trapezoid position. At this point now, I've gotten about as close as I can with the type of lighting that is utilized, meaning the top light. At this point, we would use what is called a fiber optic backlighting. And what that is with this fiber optic light pipe inserted into the ultramicrotome right here, secure it in place. Then we go over to the controller again. And remember I was saying under lighting system, our symbol of specimen holders, we now have a light coming up from the bottom. So what we would want to do is turn this light on, which would be our backlight. If we turn the backlight on, we would then turn the top light off. So that back over on the microtome, what you're looking at is a very bright fiber optic light that when inserted into the back of the knife holder will illuminate behind the knife, between the knife and the block face, and now you have an area in which you can see if you have to align your block face and knife critical approach. At this point, you would use your coarse advance knob on the left side of the stage, and that's in divisions of 5 microns per line. You would approach as close as you feel comfortable, where you see you may need to make an adjustment. Once you reach a certain point where your coarse advance is as far as you can go, you then would go to your fine advance knob. Your fine advance knob from one tall line to another on an index mark is 1 micron. So from a tall line to a short line is half a micron of advance. So if we rotate that, what you're going to see is it corresponds right over here, and it's a very precision drive, just like a scope. There is absolutely zero backlash with this stage. So it's a very precise movement. So what we would do at this point is look through our scope and go with a very fine advance, see if we need to rotate the knife to make sure that it's parallel with the block face. We may want to adjust the arc segment holder for the arc, so the tilt of the block face in reference to the knife edge, and then again an adjustment as far as the rotation of the block face, as far as lining up the bottom of the block face with the knife edge itself. Once that's all accomplished, then you can come over and we have a function called step advance on the ultramicrotome. And what I would say is you would want in the area of, let's say, 100 nanometers at least in your section thickness readout. This can be adjusted by a plus or minus button, in which if you hold the plus button down or the minus, for example, you'll notice that after a while the counter kicks into what we commonly call a turbo speed, in which it will go very fast. If you then can also push it one click at a time or hold it down, and it'll go back into a turbo speed shortly, and we're going to take it back down to 100 nanometers again. And what this is going to do for us is, using this step advance, we're looking at the specimen holder. Every time we push the button with the arrow pointing forward, it's going to move the specimen holder, which is your sample, forward towards the operator, towards the knife, exactly whatever we have set here in this section thickness. So if we do that now, okay, if you notice, the advanced totalizer is increasing exactly 100 nanometers with every push of this button. Okay. Now I see that I've need to make a minor adjustment of the stage as far as the alignment of my knife to my block face. Now I could put my hand on this fine advance and back it up a little bit and make that adjustment, but then I'd have to go forward again to get back to the same spot. It's a very minor movement, but if we use this step advance function that's on the controller, what you can do is you can push the button with the arrow pointing to the rear, and every time you push it, it's going to back up 100. So let's say back up 1, 2, 3, 4. I then come over to the upper stage again, and I make my very minor adjustment looking through the scope during this period, and make the very minor adjustment I need, then go back to the controller, and I can go forward 1, 2, 3, 4, and I am exactly at the same spot. You couldn't do that with your hand on a mechanical device, but with the controls of this unit, with the stepper motor of the advance, it's extremely exact. So now at this point, we see what other adjustments we may need to make. If we're at the point where we know that if we go any further, we're going to start trimming sections, what we're going to want to do now is turn our backlight off, turn our top light back on. Okay, now we know we've reset because it reset when we turn the Ultramicrotome on, so we don't need to do that right now. We just have our top light on, and what we want to do is we want to determine, do we want to take thick sections or do we want to take thin sections? For right now, let's go ahead and take some thick sections. That's why we're utilizing the glass knife. And what I'm going to show you is how you can utilize these memories. What we have here is memory 1, 2, 3, and 4. In memory number 1, we have 60 nanometers, which would be our standard thin sections in this silver range. Memory number 2, we have 100 nanometers. That's in your dark gold range. Number 3, it's flashing at us. The reason it's flashing is because we have increased more than 200 nanometers from the prior setting. This is a little safeguard built into the microtome. It's always going to give you a double beep when it accepts a command, gives you one beep when it wants to know, are you sure that's what you want to do? And if it is, all you need to do is push it a second time, and it will then accept it. If you don't push it a second time, it will default back to the prior setting. So at this point, let's say in memory number 4, I've got 1 micron. So we've now set the thickness we want. We've approached as close as we want to get. So now what we want to do is set what's called a cutting window. The cutting window is a position in the downward stroke of the cutting arm where the block is to slow down 2 to 3 millimeters above the knife, just pass by the knife and approximately 1 millimeter below the knife. You then want the cutting window to end so that the ultramicrotome will run at 10 millimeters a second in the retract stroke, or what we call the upward stroke. And how we set that is we do need to look through the scope and visually see that we're about 2 to 3 millimeters above the knife. Once we've done that, we then depress the top button of the cutting window. We hear a double beep saying that it has accepted that command. Now I rotate my hand wheel so that I'm about 1 millimeter below the knife edge, and then I depress the bottom cutting window button. At this point, I've now set my cutting window. What I need to determine now is what do I want my cutting speed set at. Routinely, it's between about a 0.4 to to about 1.5 millimeters a second. Anything, even at 1.5, but anything higher than that, you're not really taking sections. You're just trying to trim and cut through your embedding medium, your EPON, cutting through it and getting down to your tissue. But if we're just taking thick sections to look at for light microscopy to see if we're at the area that we want to cut, let's just put her down at around the, say, 0.5, 0.6 range. Now, what we have here is another readout. It's called the Advanced Totalizer. There's a reset button and a select button. If we hit reset, obviously it'll reset these numbers to 0. If we push a select button, what it's going to do is, you notice it says nanometers/sections. If we hit select, it's going to tell us how many strokes we've made, how many rotations of the cutting arm has this microtome made since we reset. And at this point in time, we're now ready to take thick sections, and if we'd like to, we can push the reset button once, and it's going to clear how many nanometers. If we hold the select button down and hit reset a second time, we've now cleared how many sections have been taken. So at this point, we would turn the cut button on, which would activate the drive motor, and take thick sections, take some cuts, collect them, or just use them for trimming. Set my cutting window a little higher. Sorry. Set my cutting window a little higher. Normally we would be trimming and getting, with a dry knife, we would be just trimming, and you could use a eyelash, which is very fine Dalmatian hair, or actually eyelash, just glued to the end of a stick will work just fine. Or if you're just trimming, you might want to use just a small brush to brush the trimming away. Now, once you're down to the tissue or whatever you're cutting in your block, you could then convert to a glass knife like we have here that has a water boat on it, and you would then use a syringe as a rule that's double distilled water with a special millipore filter. Got it on there good, Judy. I'll let you put it. I just didn't want to pull it the wrong way and do something wrong. Thank you. So at this point, if you are going to start collecting the thick sections utilizing a glass knife with a what we call a boat on it, you would then use a syringe that has, for example, double distilled water, millipore filters. Remove the cover of the syringe, and you would then, while you're looking through the scope, actually take the water and make it convex. In other words, ready to overflow. You're doing this so that with that convex water, you're able to get the knife edge definitely wet with the water. This is not only to lubricate the edge for the sections to float off on, or the sections to come down on the knife edge without crumpling up and distorting, but a medium for the sections to float out to be supported. So at this point, you would really set that syringe down and utilize another syringe to draw the water off so that you don't contaminate your original. Now I'm going to draw the water off until I see a nice silver surface on the water. And now I'm ready to turn the motor on and take 1 micron sections. And at this point, you can either turn the motor on or, as some people do for thick sections, it may be faster just to rotate by hand to take a couple thick sections and then possibly stain them, look at them under a light microscope to see if you're at the area that now you know you want a thin section. At that point, if you know you're ready to thin section, you can stop, collect up the sections, and at this point, for demonstration purposes, I had these removed from the Ultramicrotome. But on this MT XL Ultramicrotome, we utilize what's called hand rests. What makes it real nice is, depending on how steady your hand is one thing, but the fact is these hand rests are connected to the cover of the microtome. The cover of the microtome is on separate dampening rubber assemblies, separating it from the stage and the cutting arm. So what I'm saying is you can rest your hand on this without worrying about disturbing anything. And at this point, you would use your eyelash, good pair of high quality tweezers. You would take and collect a grid with your tweezers. Holding your tweezers, you can very comfortably and very steady then be able to collect up your sections with your eyelash, manipulating them over your grid, and then picking up your sections with your grid. You can then take your grid, go to your filter paper, dry it however you're instructed to. Put your grid in your grid holding container. And now that we've cut down to the area we want, all we need to do is take the coarse advance knob of the stage, back it up a good amount because you're going to be putting a diamond knife in here. You can then remove your glass knife by loosening the knife holder locking stud. Set your glass knife safely aside. Back out your knife locking stud. Remove your glass knife spacer. I don't understand.
The armrest is going to be set up.
I mean, you can't see. You got it. Now you would put in your diamond knife. And there are various manufacturers of diamond knives, as I mentioned earlier, at 4 degrees. Some of them, others are set for 6 degrees, whatever's recommended. Before you put your diamond knife in, always look at your included angle adjustment knob and double check what it's set for. On this particular case, I did have a glass knife set at 6 degrees, so I will want to remove my fiber optic light pipe, loosen the knife holder locking stud, and take it down to 4 degrees. Lock down my knife holder. You can reinsert your light pipe if you want to confirm your alignment. Insert the diamond knife all the way forward. Lock it down. And then go through and utilize your approach with your coarse advance, your fine advance, lateral movement if necessary, and step advance functions if necessary. But I wouldn't go at 1 micron. I would go and select one of your other memories. Let's see, number 3 we got 500. Number 2 I've got 100. Let's leave it at 100, and I would then start using my step advance to get for a critical approach. Minor adjustment, go back in with the step advance. It looks like I'm well aligned, and at this point, because I'm now in the area of the block face that I know I want to collect thin sections, if you want to know exactly how many sections you took and exactly how far you cut into the block face, it would be a good time to reset your advanced totalizer at this point. 0 for thickness and 0 for number of sections. You can turn your motor on. And as you can see, with the cutting window, the green light activates when it's running in the cutting window, running at 0.6 millimeters a second, taking 100 nanometer sections. It's taken 3 sections at 100 nanometers each, which is another one it just took, so we now have 400 nanometers we've cut in. Now at this point, you really want to have your eyelash and your hand rest up. And you should be making sure that none of your sections are bunching up on your knife edge, etc., etc. You should be watching very close when you're sectioning with a diamond knife. And remember, if you turn the cutting motor off and you're in the upward stroke giving you your yellow light illuminated, you can rotate your hand wheel backwards just a little bit, which is bringing your block up from the bottom till your green light is illuminated, and you won't be hearing any of that beeping because you're in a downward stroke. You can come across from the top and set your block on the top of the cutting stroke to stop the unit from giving you that retract beep. But if you do that, you always have the possibility of touching your block face with your eyelash, getting some water on it, something like that. So as a rule, it's best to park it down below at the bottom of your stroke. There are various different methods for section collection. You can utilize, for example, chloroform. This is a bottle of about half full chloroform. You can take, it has your cotton tip swab. All you need to do is to take this chloroform and pass it over your sections, and it will allow them to flatten out and separate. It makes it easy to manipulate around with your eyelash and collect your half a dozen sections, etc., to collect on your grid. And at this point, I think you'll see that once you become familiar with the ultramicrotome's operation, as far as the functions of the controller and the stage, etc., you'll see that this is a very user-friendly microtome and very easy to operate.
Okay, Greg, I'd like to ask you a few questions before we let you off the hot seat here. I was making a list as you were going through the procedures, and as I see it, there's about 5 precautions, and I'd like you to amplify on a couple of them maybe. One of them was have the set screw in the proper position at 9 o'clock when you're inserting and tightening the holder. Was that true?
Yes. Well, there's 2 holes. One is at 9 o'clock over here on the side, the left side, and there's also one at 12 o'clock. The one at 12 o'clock, primarily you're using that. You have to move the scope in order to lock it down. In utilizing the one at 12 o'clock, it's most often for operators that rarely remove the specimen holder from the geared arc segment holder. But if you find that you like to do your trimming in a specimen holder and leave it in there and take specimen holders in and out, it's easy to remember the 3 o'clock position for the specimen locking set screw into the specimen holder, and 9 o'clock over here. You don't have to move your scope.
Secondly, it's probably a good idea that maybe they not move the knife until they attach the stage holding the knife holder to the microtome itself. I noticed you did it before, but perhaps especially if you had a diamond knife, if you had a diamond knife in hand with the stage, maybe you'd want to attach it?
Correct. As a general rule, if you're, a glass knife is one thing, but definitely with a diamond knife, you should have your stage secure before you put it in. I believe with, I was trying to do as demonstration so everyone could see from different angles and so forth. But with a diamond knife, it's a whole different rule. They're not cheap and they're non-forgiving. So you do always want to take all the precautions and make sure everything's tight before you start doing anything with your diamond knife. Make sure it's locked down, yes.
Thirdly, I noticed the fiber optics. Does one have to be careful and connect or disconnect at a proper time, or?
With the fiber optic light pipe, it does go in and out of the microtome upper stage fairly easy. And yes, if you insert the fiber optic light pipe into the upper stage roughly, you could very easily make a rotation. It all depends on the person using the ultramicrotome.
But I noticed that you actually had it off the microtome to start with. Is that the normal position, or is it usually on the microtome?
It's usually on the microtome.
Okay, and you don't have to detach it at a certain time?
No, not unless you want to detach it.
No, I mean to the stage. In other words, if you move the stage in and out and still had the fiber optic,
you
it
mean
appears that might
detaching
be
it
a
from
problem.
detaching it from the stage. If how you're instructed on how to use the microtome is to remove the stage every time you go to change a block, etc., then yes, you would want to remove it from the stage in order to remove the stage from the microtome. But if all you're doing is backing the stage up, as you can see, there is quite a bit of travel. Glass knife wouldn't be a problem, but diamond, I'd recommend removing the fiber optic light pipe from the stage, put the stage in a secure place where the knife is not going to get damaged, and then change your blocks, etc., and then go back, place it on your on your lower stage, insert your light pipe, bring it up carefully, and I still have not let go of that stage, and now lock it down.
Fourthly, on this new microtome, can we turn the hand wheel in a counterclockwise direction?
Without doubt, it's not going to hurt a thing inside the ultramicrotome. You can rotate this backwards as much as you'd like, as imagine as fast as you like. We've tested this thing very thoroughly. The only thing you have to remember is it's not backing up the advance. The reason we did that is we have the original 1953 MT1 hand crank design, and it's during approach you'll find you get a habit of rocking the cutting arm up and down in order to do the approach to the knife.
Do we want to be careful when the motor's on not to operate it in a manual mode?
If the motor is on and you try and rotate the hand wheel, you're going to feel immediately that you're fighting against the drive of the belts, and it's I'm sure not good for the drive motor, but you're not going to accomplish anything because those belts are going to override.
So it's
They're
something
very
you don't
strong.
want to do, though.
You don't want to, if the motor is on, there's no need to have your hand on the hand wheel.
So is there anything else about the microtome that we should take particular precautions?
The Ultramicrotome is you know, how many generations have been built, and this is the latest. And what we've done is we've tried to manufacture this system, this unit, as sound and rock hard as possible. The only thing I can think of on the entire microtome is you do have to remember that you keep moving this advance forward for the stage, the coarse advance and the fine advance, and once you get there you finish sectioning, move your stage, put your upper stage back on, and it's easy to get in the habit of moving the stage forward constantly. You got to remember, one of these days you got to back it up. So the rule is anytime you need to reset the microtome because it starts beeping at you towards the end of the advance, or just as general practice when you sit down to cut, I call it a rule of thumb. Check that the plates of the lower stage are relatively equal, and you don't have a big step between the two plates, because this top plate moves front to back, the center plate moves right to left, and the bottom plate is part of the microtome. So the right to left movement is not at issue. But the top plate, yeah, you don't want to have much more than about a 1/4 inch shelf here. If you do run out of travel, what happens is the coarse knob you will be able to feel with the coarse knob that you've run out of travel, and with a fine knob what you'll notice is you'll rotate it and you just won't have any movement.
Oh, that's very helpful to know. Also, could you, before you finish, look at the control panel and just review quickly the controls that are on the control panel, since they're new to most of us?
Alrighty, be glad to. First one we have is what's called the reset button, and that is for the advanced mechanism only. This reset button, when depressed, the red light will illuminate. There are 200 microns of advance in the microtome, and if you have used pretty much all of the 200, you're going to need 20 to 25 seconds to reset. So if I hold it right now, we've gone maybe 20 microns. You saw how short it was that the light was on. Lighting system, top button turns the light on, illuminating the specimen from the top. Bottom button illuminates the specimen from the bottom. Step advance function, specimen holder, arrow pointing forward. Every time we depress that button, it's going to advance the specimen exactly the amount you have in your section thickness. Reversed, cutting window settings, cut button to turn the motor on, and your position of your cutting arm, downward stroke green, upward stroke yellow, cutting speed, section advance, totalizer, and then your store in your memories. And if you adjust something and you want to store it, whatever light is illuminated, you do have to push store.
Well, thank you very much, Greg. This microtome should be a joy to use. And we hope that all the students and everybody that's watching the tape has very instructional tape now on how to use the microtome. And of course, our students, be sure to use our standard operating procedure for using our new microtome, this RMC MT XL that we're very pleased to have. And we appreciate, Gregg, you taking your time today to show us how to use the microtome. Thank you very much.